Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Stellar Cores Drawing Energy from the Sun. Now, the evidence that a system of stellar cores has invaded the solar system is overwhelming. And a large number of these objects have congregated around the sun and have been observed in the sun's corona now for years. These objects make plasma connections, thus draw matter from the sun, which weakens the sun. And in this article, I detail the mechanisms through which stars generate energy and how stellar cores weaken the sun. And you see one of these objects in the sun's corona. As you can see, it's a spherical object. It has stripes. You can clearly see that this is a spherical object because the stripes are curved and thus follow the curvature of the object. We can see that it has a plasma connection here. This plasma that seems to be from the sun's corona, it seems to be attached to the object and following it as it moves in its trajectory around the sun. Now, all objects in the universe develop a negatively charged outer layer, and this is as a result of the gravitational interaction, which I've written many articles about. I've basically written a book about it, and that's my third book is specifically on the subject. And you may find some more information on. I cannot go through it every single time, but Article 181 entitled Stellar Cores and Deciphering Gravity, and Article 182 entitled Einstein's Dream Realized, Unified Field Theory of Electrogravitation explains how gravity really works. And gravity has two parts to it, so it's similar to the electrostatic interaction. It has an attractive and a repulsive part to it. And the repulsive part causes all objects in the universe to have a positive interior and a negative exterior. And so this is the area in the sun, it will be called the sun's corona, where electrons predominate. So galactic nuclei, like all other objects in the universe, have internal positively charged cores and a negative outer layer. And this causes an electric field to be set up between the core and the outer layer. So wherever you have positive charge separated by negative charge, you of course have an electric field which points outwards from positive towards the negative. And then there will be a potential difference associated with that electric field. And this potential difference will cause discharges to occur between the layers. In other words, there will be discharges or lightning in the sun's outer layer as a result of this potential difference. And discharges cause photons to be emitted. And so a photon with an energy of 940 MeV, and I describe in Article 196 entitled Stellar Cores, Particle Mass and Replicator Technology, how I came to that particular number. And so when a photon has this energy or more, it splits into a proton and an electron when it moves through a region of high enough electric field. But there is a high enough electric field as long as it's a large object that is able to maintain a large potential difference. So the moment the photon is emitted, and it is of enough energy, and there's this electric field there, the photon splits into a proton and an electron. And this is what I call a particle creation event. So these electric discharges by the galactic nucleus lead to matter creation events in which protons and electrons are created from the high energy photons. Now, photons are carriers of gravitational energy, and so part of this energy gets converted into the mass of the particles, and another part is equally shared between the particles and will continue existing as gravitational energy. And then it will be in the form of photons within the particles. And this is illustrated in this image, that it seems as if the particles, still not manifested as particles, exist within the photon as energy. And whenever the photon moves through a region of high enough electric field, then it splits into the particles, which now have mass. So some of the photon energy went into producing that mass. Whatever's left of the photon energy then remains as photon energy, but then it exists within the particles and it's shared equally between the two. Now, some of the protons and electrons combine to form neutrons. Protons and neutrons then start fusing into many different nuclei. The nuclei then combine into solid matter and thus condense into objects, that is, stars, planets, and so on. The heaviest nuclei will attract each other more strongly than the lighter nuclei, and thus the densest part of the condensing objects will have the heaviest available nuclei at the center. This also means that the largest objects will have the densest cores. Among the heaviest nuclei in the cores of these objects, there will be many unstable nuclei, which will decay into lighter nuclei for the next million or billion or even billions of years, and therefore generate energy in the form of photons. Thus, the large objects turn into stars, small objects turn into planets, and the leftover crumbs of matter condense into asteroids. Both stars and planets have large enough cores to generate photons or gravitational energy from fission, but stars, because they are much larger, will generate much more energy. So all the objects that form, and they form as a result of the attractive part of the gravitational interaction, which causes two protons to attract each other, and thus causes nuclei that have the most protons, so the heaviest nuclei, to attract each other more strongly than the lighter nuclei. So that means that the core or the object starts condensing from the heaviest and the densest part of the matter that has fused into nuclei. So the heaviest nuclei will be right at the center, and there will be layers around that contain lighter and lighter nuclei until we get to the surface, and the surface will contain the electron, or mainly electron layer, which is at a negative electric potential. This outer layer here will contain mainly hydrogen, because hydrogen or protons, an hydrogen nucleus is basically just a proton. So the least dense matter will be at the outer layer, and that the least dense nucleus is, of course, a proton. Now, I have explained this in Article 185, stellar formation. Stars are formed from light, if you'd like to know more details about that. So these objects will condense into material which decreases in density with distance from the surface. The sun's upper layer, or the corona, is the sun's upper atmosphere and is in the gaseous phase. The corona is also the sun's outer negatively charged layer. The sun's chromosphere is the layer below the corona and seems to vary in density from liquid to semi-liquid, and the surface layer, which is the photosphere, is in the solid phase and is the densest of the surface layers. And this is explained in Article 134, entitled Planet X Creates a Gash in the Sun. And in that article, I actually show how the stellar cores, as they lift matter from the sun, you can actually see that the lower layers, the lower part of the chromosphere, seems to have this semi-solid sort of seems to be made out of a semi-solid material that seems to retain its shape for quite a while, as if it's made out of wet clay. Now, the sun produces continuous discharges as a result of the electrical potential difference between its core and its outer layer, and thus continuously has matter creation events in a similar manner to the galactic nucleus, but at a much smaller scale. And I detailed that in Article 175, entitled How is the Solar Wind Produced? The particles generated are protons and electrons, as I've mentioned before. Fusion will then occur so that heavier nuclei form. Most of the electrons are retained by the sun's corona. Ionized atoms such as protons, helium nuclei, and other nuclei of other elements up to iron, or it doesn't actually have to be just the nucleus. It could just be atoms that have less electrons than they would have had if they were neutral. So these are basically ions. Will either be pulled in towards the sun's surface or will be ejected outwards through the corona and will end up in one of the sun's nebula rings. And the heaviest positive ions, such as iron, will end up in the nearest nebula ring, which is also called the sun's zodiacal ring, and the lightest, such as hydrogen, in the furthest nebula cloud, which goes out to beyond Pluto's orbit. And I detailed that in article 185 entitled Stellar Formation: Stars Are Formed from Light. So this is illustrated in this image. So we have the sun. This is the sun's interior, which is positively charged. This would be the chromosphere, which is between the surface of the sun, would be here, the photosphere. This would be the interior, which is all solid. This is the corona, and there will be discharges. Photons are emitted, and then the photon, because it's moving in a region where there is a high electric field, turns into particles, a proton and electron. And this mechanism leads to the sun producing its solar wind and CMEs. It actually comes from particle creation events through this mechanism. Now, whenever heavy nuclei fission into lighter nuclei in a star's core, a photon is emitted, and the two resulting nuclei have lower mass than the original heavier nucleus. The fusion of light nuclei into heavier nuclei also results in the emission of photons and a heavier nucleus of lesser mass. And this is what's occurring in the corona, the outer layers. As these particles emerge, fusion will occur and heavier nuclei will start forming. Thus, a star is formed from photons or from light emitted by the galactic nucleus, which gets converted to mass. Then throughout its lifetime, a star converts this mass back to light. This conversion occurs both in the core through fission and in its outer layers through nuclear fusion. Now, after billions of years of undergoing this conversion, a star ends up with matter which has low effective mass. As most of its mass and gravitational energy, and by gravitational energy here I mean the non-massless form of it, which remained this is the gravitational energy which remained in the non-massless, i.e. photon form, within the particles is used up. And this is why then it seems that the stellar cores seem to have such low effective mass. In other words, the gravitational attraction exerted by the stellar cores is much weaker than we would expect from their size or the matter they seem to be made of. In fact, the outer layer has such a low effective mass that the debris resulting from the stellar cores shedding their outer layers floats in space around the sun as if the sun exerts no attractive force on it whatsoever. And what we can see here is an image of the sun. This is a cactus image, and you can see one of the large stellar cores within the CME, and it seems to be interacting with the sun. We see lots of plasma that seems to be streaking past it, but what we already see is these little spots of well, some are black and some are white. And these objects must be quite close to the sun, because whenever the sun ejects a CME, we can see these moving as if buffeted by a wind. So these objects must be quite close to the sun. They're just floating around as if the sun exerts no force on them. And this shows that this material, which is mainly it's debris that comes from the stellar cores, because they share their outer layers, because these outer layers are just shells. They are matter with very little gravitational energy. So they do not exert an attraction on anything else. They just float around. And so the stellar cores seem to shed this outer layer. They seem to have matter within them that has higher gravitational energy, at least in the form of mass. So that they are able to pull some matter away from the sun towards them, but they have to come very close to the sun to form their vortex connections, which are gravitational connections, because they are so weak gravitationally. Now, the stellar cores absorb matter from the sun. They will most likely first absorb electrons from the sun as they enter the sun's corona, as they are like a superion and thus depleted of electrons. And the stellar cores come to the sun because they are attracted to the sun's outer layer of electrons, and the attraction is the electrostatic attraction, which never decreases in strength no matter how old the star is. So the fact that it's still somewhat positively charged on the inside causes it to be attracted to the sun's negative outer layer. So it's the electrostatic attraction that actually brings them to the sun. So as they absorb a large amount of electrons, the sun's electric potential difference will quickly decrease, and it will therefore stop having electrical discharges, which is what generates light. Matter creation events will also stop, and thus the sun will also stop generating a solar wind at those times. By drawing matter from the sun, the stellar cores are removing the sun's gravitational energy. Gravitational energy is the massless or photon form of energy in the universe. This massless form of energy is shared throughout the whole object containing this energy. Heat or vibration of particles is a manifestation of this massless energy within the particles that makes up a solid object, and this is detailed in article 191 entitled The Photon Universe. It is all made out of light. Thus, heat is actually photon energy or gravitational energy, and since heat flows across a whole object until the whole object is at the same temperature, gravitational energy or photons within matter will be shared across the whole object. Thus, the stellar cores, by drawing matter from the sun, are drawing heat from the sun. Hence, even though the sun continues to generate gravitational energy, photons in its core through fission, this energy is being absorbed by the stellar cores. And if they continue to absorb more energy than the sun is able to generate, the sun's overall gravitational energy will keep decreasing. Since the sun uses its overall gravitational energy to produce the gravitational repulsion between protons and electrons to generate its electric field, and therefore its electric potential difference, the electrical potential difference will decrease, which will cause electrical discharging to also decrease, and thus light emission to decrease. The sun will therefore become progressively darker. Now, so here we see illustrated the electric field that is generated within these objects because there is a positive core and a negative outer layer, and therefore an electric field between these two layers. Now, at the same time, the sun's ability to create matter will decrease, which will decrease its ability to create the solar wind and CMEs, and it will make it difficult for the sun to replace the matter that is being withdrawn by the stellar cores and that is leaving the sun as solar wind. So we expect that the sun is still ejecting ions as a result of the fact that they are repelled by the electron layer. So they're moving outwards, going into the nebula rings, and yet the sun is producing less creation of matter because its electric field is decreasing, the electric potential is decreasing because the sun's overall gravitational energy is decreasing. So this means that this potential difference has to decrease because the repulsion between protons and electrons decreases as gravitational energy decreases. Now, this means that the sun's outer layers will continuously decrease in thickness, the sun will lose matter. It will lose it to the stellar cores, and it will lose it because it's not replacing whatever ions are being ejected. It is still able to eject the solar wind from the corona. So at the same time that the sun is able to emit less and less light, it will have less and less matter in its outer layers. This will continue until the sun has no outer layers left and will then become a stellar core itself. As its gravitational energy decreases, it will eventually become impossible for the gravitational repulsion between electrons in the outer layer and the protons in the core to repel each other sufficiently in order to overcome the electrostatic attraction between protons and electrons. And the sun will then develop an outer neutral layer and eventually a neutron layer, because the protons and electrons, if the gravitational energy is too low, will actually collapse into a neutron, and it will thus become a dead star as well. And here what is illustrated is the electrostatic and the gravitational interactions. They in a way oppose each other, because in the electrostatic, protons and electrons attract, whilst in the gravitational they repel. And then in the electrostatic, two protons will repel each other, whilst in the gravitational they will attract each other. This is what causes the gravitational attraction that we all know about between different objects in the universe. It's the fact that protons within that matter attract each other. And these two interactions, or through these two interactions, every mechanism in the universe can be explained. So we basically have only two interactions that play off against each other all the time. So one leads to the other. The electrostatic interaction is of the same strength in all cases. The gravitational interaction is not. The strongest part is the attraction between two protons. The proton and the electron is not as strongly repelled as two protons are attracted to each other. The weakest is the attraction between two electrons. So, in conclusion, as stellar cores draw matter from the sun, they decrease the sun's overall gravitational energy, which in turn decreases the sun's electrical potential difference, the degree of electric discharges in its atmosphere, and therefore the light emitted by the sun. Particle creation events, and therefore the solar wind, will also be reduced as a result, and the sun will eventually turn into a stellar core or a dead star as well. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.